After 6,400 years of undergoing alpha decay, a sample contains only 6.25% of the radium nuclei it initially had. What is the half-life of these radium nuclei? So for number 9, we're going to first use method 1, which is just simply common sense. So originally we have 100% of our radium nuclei, but then it decreases all the way to 6.25%. So by dividing by 2 each time, which we get 50%, dividing by 2 again, which we get 25, dividing by 2 again, which we get 12.5, and dividing by 2 again, which we get 6.25%. Since we had to divide by 4 times, we could just divide 6,400 years over 4, which half-life gets us 1,600 years. Next, we're going to use method 2, which is n of t is equal to n of 0 times e to the negative wavelength of t. So n of t, we end up with 6.25%, and originally we had all of our material, or 100%, times e to the ln of 1/2 over t of 1/2 times t. We can then divide by 100% on both sides. Which then we get 0.0625. Which is then equal to e of ln of 1/2 times t over the t of half-life. We can then ln both sides, which cancels out the e, and we get ln of 1/2 times t over t half-life. We're trying to find t half-life, so we can reorganize the equation like this. And then the t of decay is 6,400 years over ln of 0.0625. We just need to plug this into our calculator. We can find t of 1/2. 0.5 over ln of 0.0625. Which we then get 1,600 like before. So our answer for number 9 for half-life is 1,600 years.